next phenomena of total internal reflection, mirrors. Now this mirrors is a very common phenomenon which you observe in a desert, very hot places where the temperature is very high. Now this mirrors, it is an optical illusion of water observed in a desert in which the inverted image of a distant object can be seen, can be observed along with the object itself in a hot day. And this is due to total internal reflection. So this is the definition of mirage. Now, according to the definition of mirage, now what we try to explain is that it is an optical illusion of water. Okay, so now let us consider this figure here, and this is the land. Okay, and here is a water. Actually, water is not there, but some sort of illusion it appears on the observer. Observer is at sea. Some illusion will appear to the observer that there is a presence of water just below or just near the tree. That means how that illusion will appear, that because the inverted image of this tree can be seen here, and this inverted image can be seen, okay, in the water. Actually, water is not there, but some sort of illusion will appear here, and this illusion is appearing due to the total internal reflection. Okay, and you can see the inverted image of the object as well as the object in a hot day where the temperature is more than 40 degrees Celsius. Okay, now let us consider the sand. Okay, in summer the sand gets heated up, it becomes very hot, and the air which are very close to the sand, they also becomes hot. Okay, and due to this condition, the refractive index which are very close or very near to the sand, it becomes very least. Refractive index becomes very least, and as you go up, okay, the refractive index goes on increasing. That means the refractive index is very least near the hot sand, because near the hot sand the air is very hot, the air is heated, that means the air is very hot. So when the air is very hot, the refractive index becomes very less or least. Okay, and when we go away from it, the refractive index increases. Okay, now let us consider a ray of light coming from A. Okay, and when it comes from A, that means it comes from it. The ray of light is coming from a height, and it comes closer to the sand. That means from the height it is coming down. So when the ray of light it comes down near the sand. Okay, what happens is that now this ray of light it crosses various air layers. Okay, various air layers are there, and these air layers are parallel to each other, and this ray of light they passes through different air layers. So when it passes through different air layers, okay, what happens is that now this light is passing from the denser towards the rarer medium. That means the refractive index near to the sand is very least, so the medium is considered to be as a rarer medium. So the ray of light is passing from a denser towards the rarer medium. So when the ray of light passes from the denser towards the rarer medium, what happens is that at the position B, okay, at this point B, okay, the ray of light will be drift away. That means they goes away from the normal. Okay, because it's passing from the denser towards the rarer medium. So when the ray of light passes from the denser to the rarer medium, it bends away from the normal. And finally, what will happen is that a condition will appear here in which the angle of incidence will be greater than the critical angle. Okay, the angle of incidence will become greater than the critical angle. And when the angle of incidence will become greater than the critical angle, okay, and therefore what will happen? The ray of light, it moves upward. It moves upward. So, and this ray of light, when it is seen from the point C, it appears that the ray of light are coming from the point D. So that means that this D will be the virtual image of a point A. That means the virtual image of the tree A. Okay. So this way, due to the total internal reflection of light, the mirage occurs. So it is only the optical illusion, because due to this optical illusion, the false image or the false image as well as the inverted image of a tree will appear in the water. So this is about the mirage. Now the next point is application, uses of optical fiber. Okay, that means the uses of total internal reflection. One of the use of total internal reflection is optical fiber. Now, what are these optical fibers? These are a very long thin strand of very fine quality quartz glass. That means there is a quartz glass, and these quartz glass are very thin. Okay, they are very thin strand of quartz glass of about and having a refractive index of 1.7. So these optical fibers are made up of quartz glass. Okay, and the diameter of that quartz glass is considered as the diameter of a human hair diameter. They are very tiny, they are very small. Okay, and these quartz glass are a very thin strand of very thin strand of a diameter of a human hair. Okay, and these quartz glass are made into a bundle. Okay, a very thin strand of like a human hair, a very thin strand are there, and this kind of quartz glass are made into a bundle and form the optical bundle, or we call it as a very thin, this optical fibers, which we call it as a optical bundle. Okay, and this optical bundle will transmit the light. Okay, they transmit the light due to total internal reflection. Okay, now these optical fibers, especially these are used in a telecommunication. These are used in transmitting a light. Okay, these are used in some medical science, in the medical purpose. Okay, to make the endoscope, instrument endoscope. Okay, so endoscope, these are the instruments which are used to see the internal organs. So these are used, all these are used in the made up of optical fiber. So these are the use of optical fiber. Okay, now in the next class, now we have come to the end of this chapter. In the next class, we will start a new chapter, that is lenses, refraction through lens. Thank you.